In this video, we are going to discuss about the stability of two bodies. One is the bigger body denoted by CD, and another small body which is denoted by AB. And this small ball is placed inside the bigger one. Now we are to consider the stability of this configuration. Now let us first think about the basic physical features of these two bodies. We assume that the bigger body CD touches the ground level at the point A, and its radius of curvature is denoted by OA equal to, let's say, capital R, while the smaller body which is inside the bigger one has radius of curvature, say, small r. Let us denote it the position of the center of curvature by O1, and we should also depict this by O1 prime. Now there are two smaller bodies. Let me explain. It has been drawn with green ink. Now this is the initial position and this is the displaced position, and you consider virtual displacement or small displacement, with respect to which we consider the stability of the initial position in which the smaller body is rested on the bigger body at the point A. Both of them touches or meets at the point A, and which is the lowest level. Now we displace it so that it turns to this position where this A moves to A prime, B moves to B prime, and obviously if we tilt it this side, so this line gets shifted, and the new position of the center of gravity, this G represents the center of gravity of both the bodies, combined system, center of gravity of the combined system, and we assume the height of this CG from the lowest point A to be H. So these are the features, and we should remember that these three lengths determine the stability of the equilibrium of these two bodies. I hope I have been able to describe the basic situation here. I repeat, there is a bigger body placed in this horizontal plane and a smaller body placed inside it, and we tend to find the condition of stability of this equilibrium, and for determining it we shift or displace or give a virtual node with respect to the symmetry of the system, so that the small body is shifted rightwards. We may shifted it leftwards also. So what is the angle of movement? We can see that this bigger radius is shifted or rotated by an angle theta, let's say, and the smaller one, this one O1A, it gets shifted to A prime O1 prime. So we can easily see that this whole angle is phi. Let's name it as phi, this one. Let us name it as this O1 prime G A prime, angle O1 prime G and A prime. This is phi. And since this is theta, so you can easily measure that this is also theta. If we draw a line which is parallel to this vertical line OA. This is the O prime M is drawn the vertical line from the point O1 prime, and O1 prime is the new position of O1 in the shifted position. And through A prime we also have drawn another vertical line which is parallel to OA. So these three lines AO, O1 prime M, and the vertical line A prime, let us mark it as L, A prime L, they are all parallel. A prime L parallel to O1 prime M, which is drawn perpendicular downwards from O1 prime, and OA, the bigger radius in the initial position. And you can easily see that since these are this line and this line is parallel and this cuts it, so this angle is theta. M O1 prime A prime, M O1 prime A prime is nothing but theta, as well as G prime A prime L is also theta. Angle G prime, sorry, O1 prime, not G prime, O1 prime A prime L, O1 prime A prime L is also theta. Now the construction, we have drawn another vertical line from G prime, the new position of the CG of the smaller body, G prime N, and a horizontal line through O1 prime meets it at N. So what is the angle? If we draw this triangle here in a bigger way, this is O1 prime, this is G prime, and this is N. I should shift it. This is O1 prime, this is G prime, and this is N. This is the small triangle drawn here. We have dropped a perpendicular downwards from G prime, and we have drawn a horizontal line from O1 prime, the new position of O1 in the tilted frame. They meet at N. So we have a triangle O1 prime G prime N here. And since this is phi and this is theta, so this is obviously phi minus theta, and this is obviously phi minus theta. Now the physics is that the weight of the body is acting from G prime downwards. And since the smaller body is shifted and A prime is the new point of contact, the reaction moves upwards. Isn't it so? So the perpendicular to this tangent is this, and these two force brings this body to the original position if and only if this O1 prime M is shorter than A prime M, because then the reaction and weight will move it back to the previous position. Otherwise, if this G prime goes beyond that, or this O1 prime becomes bigger than A prime M, then it is further shifted. It is quite obvious that if this smaller body weighs more in the right part than in the left part, the symmetry will be unstable. So for the condition of stability of this equilibrium, we must have this O1 prime M N shorter than A prime M, so that the weight downwards and the reaction upwards tilt this back to the previous position. I am drawing this triangle here again, O1 prime G prime N, and we know that this angle is phi minus theta. Since this is theta and the whole angle O1 prime G prime A prime is phi, and that is a measurement through which the smaller body rotates. The smaller circle radius rotates, and we know that the larger radius rotates small angle and the smaller radius rotates large angle, so that the arc length remains the same Isn't it so? R theta is the arc length and small r phi is also the arc length through which the body is rotated or shifted. So they should be equal. So what is the measurement of O1 prime m? N. Since we know that AG is H and O1A is R, so O1G or O1 prime G prime is R minus H. And since this hypotenuse is R minus H, so you can easily see that O1 prime N, which is the perpendicular of this triangle, measures sine of phi minus theta. Isn't it so? Simple. And this must be less than A prime M. And what is A prime M? This is the triangle. Isn't it so? So you don't need to draw it. M, O1 prime, A prime. And this angle is theta. This is theta, this is also theta. Angle M, O1 prime, A prime is theta. And what is O1 prime, A1 prime? O1 prime, A prime. This is obviously small r. And so this measurement is small r sine theta. Easy to apprehend. So from this figure, we see that the condition of this equilibrium being stable necessitates that this arm O1 prime N must be less than A prime M, so that the weight of the smaller body and the reaction in the tilted position gives us a couple which put it back to the previous position. And for this is required. And now if we just use this relation, which gives us that phi is equal to capital R by small r into theta, we divide with this r and it becomes 1 minus h by r, simple, and we put r by r theta in place of phi, so that this becomes r by r minus 1 into theta, and here we have sine theta. Since we are considering the displacement as virtual displacement, so this phi, theta, they are all very small angles, and we can easily infer from this relation, if this theta is a very small angle, we just replace sine theta by theta and sine of r by r minus 1 theta by r by r minus 1 theta. This is permissible because for all small values of theta we have sine theta tending to theta. This is a concept of limit. So we reach to this relation, which is nothing but, if we cancel theta from both sides, it looks like this. Okay. So this is h by r minus 1. This is h by r minus 1, because this is h minus r. H minus r. Here it was, you remember, O1 prime G1. This is h minus r. So here we have h minus r sine phi minus theta less than r sine theta. I am again writing it to ward off this confusion, and divided with this r here, so it becomes h by r minus 1, not. And here we have substituted in place of phi here r by r into theta, and we have taken this theta common, so it becomes this, and then we have replaced sine theta by theta only, and this theta cancels out, and there is 1, and we have arrived at this relation. And from here we see that it turns out to be hr by r square minus r by r minus h by r plus 1 less than 1. So we can easily cancel these two 1 and we have 0 here, and we can replace this inequality by this, and then we can cancel this r from both sides and divide with this hr here, so that this becomes 1 by h plus 1 by r. So this becomes 1 by h plus 1 by r. And to give it a very symmetric form, we tend to write it as this inequality. We tend to write it as 1 by h greater than 1 by r minus 1 by capital R. 1 by h greater than 1 by r minus 1 by capital R. So this is the condition of stability, and you can easily now infer that since capital R is greater than small r, so 1 by r will be greater than 1 by capital R. And this is a positive quantity, but this should be less than 1 by h, where h is